Welcome to another part of the ISM course in Statistics 1. This time with a unit on measures of distribution, and in particular with a unit on skewness and kurtosis. Let's jump right into it. We can start with skewness and first take a look on the mathematical definition of skewness. And that's the formula here. We see this looks quite familiar. Why? Well, it's more or less the distance from the mean, but not as with the variance, to the power of 2. And it's not just simply the distance to the mean. The distance is also divided by the standard deviation. So it's basically the standardized distance to the mean, or the standardized value. We recall with normal distributions we can standardize variables by subtracting the mean and dividing by the standard deviation. So this is the standardized value to the power of 3. So similar to variance, but slightly different. Okay, what are we going to use the skewness for? And for this we can take a look at two exemplary distributions. The first one looks like this. Here we see a lot of our observations are relatively small. So we have a lot of small values and only very few relatively high values. In this case, we have one extreme example. The other extreme would look like this, where we have basically no small values, but a lot of large values. Well, what would lie in between would be something where they evenly distribute. Mostly are in the middle. We have a few large, few small values. So in the middle would be something like the normal distribution. And the normal distribution, maybe you've seen this or heard about it, it's symmetrical. Well, obviously those two distributions here are not symmetrical. In particular, we call them, the left one is rightward skewed. So whenever we have a lot of small values, it's called rightward skewed. And if we have a lot of large values, it's called leftward skewed. So the right or leftwards, this always relates to where do we have relatively few values of. So in the left figure, we have relatively few large values. So the right part of this figure, there's almost nothing there. And that's why it's called rightward skewed. The other way for the leftward skewed. We can also explain this in a different way. Well, we have the definition for the skewness above. When this indicator is larger than 0, it's rightward skewed. If it's smaller than 0, it's leftward skewed. So, meaning if it's positive, this means values farther to the right, that's rightward skewed. Leftward, that's values farther to the left, unlike the line of all numbers. That's a different way how we can remember what means leftward, rightward skewed. Okay, this was already everything we can mention on skewness. Do we have a lot of small or a lot of large values? Or, this would be the case if this skewness is 0, is it symmetrical? Okay, however, I said we have two measures of distribution, skewness and kurtosis. So let's take a look at kurtosis as well. Well, this looks more or less the same like the skewness, with the only difference. With the skewness, we had our standardized values and we took them to the power of 3, and here we do it with power of 4. So it's pretty similar to the skewness. However, the basic idea is slightly different. This we can see when we take a look at the different graphs. So here we always have something as compared to the normal distribution. So the fat line, that's the specific curve we're comparing here, and the thin line, this is always a normal distribution. So basically it's 2 times the same normal distributions, but if we take a look, the axes actually differ. So what we would call the y-axis, they are different. The left one goes only to 0.25, the right one goes to 0.6. So with this in mind, what we see in the left figure The middle part, that's way below the normal distribution. However, the tails, so the outliers, the extreme values, they are way above the normal distribution. In the right figure, it's exactly the opposite. There we have a lot of values in the middle and very few values to the left and right. So our tails are very thin. In the left one we have fat tails, in the right one we have very thin tails. Tails means always the extreme values, the very small and the very large. And we have names for this. The left one, that's called Platykurtic. The right one is Leptokurtic. Okay, how to remember this? Whenever we have a curve which is relatively flat, so it's way less steep or something like the normal distribution, if it has fat tails, that's Platykurtic. On the other side, if we have a lot of values in the middle, so it's like a pointed needle, that's the right figure, that's Leptokurtic. And well, how to remember this? I said in the left figure, we see it lies in the middle below the normal distribution, and the right figure, the middle is above the normal distribution. And well, the normal distribution has a kurtosis of 3. So the left one, where we are below the normal distribution, is smaller than 3. And the right one, where we're larger than the normal distribution, there the kurtosis is larger than 3. So this is one way to remember this. A different part, in many cases you might see a different definition of kurtosis, which means you take the normal kurtosis and you calculate -3. If you do this, some people, as I said, call this kurtosis. Mathematically correct is the term excess. This means if we have a curve which has a negative excess, it's Platykurtic, so it looks like the left figure. And if we have a distribution which has a positive excess, this is a Leptokurtic distribution, so it looks like a right figure. So it always depends. Some people call, as I said, the excess also kurtosis, or call it kurtosis excess. But from the definition, kurtosis is what we have here. It's always positive, and it's either smaller than 3, then it's Platykurtic, or it's exactly 3, then it looks like the normal distribution. This is also called mesokurtic. Or if it's larger than 3, it's called Leptokurtic. So we can also then say the Platykurtic ones, they're rather heterogeneous, whereas the Leptokurtic distributions, they're relatively homogeneous. So the values are all relatively close to each other. And well, with this concluding remark, we also arrived at the end of this session. I hope you enjoyed listening to it and you took something away from it for you. Well, if you want to see more of this type of videos, feel free to visit the rest of this playlist and the rest of this course. So until next time, see you and goodbye.